Okay, two after the hour, and looks like we've got most of our attendees joined. I think we'll get started. So thank you and welcome to Minimizing Risk in VDI Implementation with Pivot3's policy-based hyperconverged infrastructure. My name is Blair Parkhill. I work for Login VSI as the Director of Products. On the call today, we also have Vikram Bellaprakar, who's Solutions Marketing at Pivot3, as well as Keith Hageman, who's the Technical Marketing Engineer there at Pivot3 as well. These are folks that I worked pretty closely with throughout this entire validated by solution, and it's my pleasure to welcome them today. So before we get started, I'd like to introduce a little more about Login VSI and what we're all about and how we how we work through this validated by program with Pivot3 to produce some really great results. So with Login VSI, we've come about and have become quite popular in the VDI and server-based compute market due to a number of factors within VDI. And those factors include a complex technology stack, which can be hard to manage when it comes to performance tuning. Desktop migrations are definitely top of mind in the VDI market lately, especially as we see Windows 7 go end of life early next year. And as well as for server-based compute on Windows Server 2012. That was the end of mainstream back in October 2018. So we're seeing a lot of migrations in the VDI and SBC space. Of course, many of you are, I'm sure, fully aware of the semi-annual channel release of Windows 10, which, as we've seen over and over again, comes with a performance impact in terms of each update. And getting your hands around those can certainly be a challenge. Security updates, you've probably also seen Meltdown Inspector, L1TF. There's just been a whole slew of vulnerabilities that we've had to compensate for that have also had, an impact when it comes to performance. And then lastly, application compatibility and performance degradation over time are all of these growing challenges within VDI that we as a company, Login VSI, have chosen to really focus on and provide the best solutions in the market to get our hands around managing this change within VDI. And of course, that change risks the great end user experience, right? As performance changes, and that end user experience is definitely going to change. And our goal here is to make sure that we get a great end user experience despite the change, so we can get ahead of that change and make sure that we never jeopardize that end user experience and the responsiveness of the desktops in VDI and server-based compute. And of course, this is an ongoing thing, an ongoing management process that we're deeply ingrained into. And of course, using hyperconverged infrastructure like Pivot3's HCI is a great way to manage that cost and scalability and save quite a bit of time when it comes to testing those changes. The performance stack is the big part of managing this change and really getting your hands around where is that change happening, how can we improve the performance of that change, and also where we can do a lot of the optimizations around that. So sorry for the background noise. The challenge in VDI is that you're testing a complete system. And with Login VSI, that is our goal, not to just test storage or CPU or memory, but to focus on the entire system as a whole. And in the case of the validated testing we did with Pivot3, this is definitely our goal and something that we were very thorough in testing. So it can be a challenge because there are so many moving parts, as you can see on the performance stack, but it's also a benefit because we're testing the entire system. We know that all of the components within the solution are behaving well and behaving to the top of their performance capabilities. Now, of course, there's a lot of things in this stack, and we're choosing to focus on just a handful of those as we focus on the hyperconverged infrastructures here. And the good news about the performance stack is, while there are a lot of layers here, just focusing on about 20% of those layers will get you a big bang for your buck, right? You'll get 80% of the performance just by tuning 20% of this. And a huge part of that tuning in the stack has to do with the Pivot3 architecture that we're using for this validated reference architecture. So the storage, server CPU, memory, BIOS, all of that stuff is where we're focusing on a lot of the performance benefits that you're getting out of the solution today. So with a lot of this change, it can definitely slow you down, and to really kind of speed up your implementations and speed up your end user experience and all that, Login VSI uses what we call virtual users. And these virtual users simulate real human interaction on the digital workspace to push the back-end system and to also get a good idea of how that system is going to respond under stress. We have two products. One is Login VSI and Login PI. For Login VSI, we're focused on the benchmarking, and that's basically pushing an entire back-end system at large scale to make sure that when it's under great stress that it can respond well to the end users. It can answer questions like how many users can I run on the server or this cluster, which OS or Office version runs best in this environment, and where or how should I run my antivirus software. These are all great goals for doing benchmark testing. As you get forward in your solution deployment, you're going to have a production environment, and continuously testing that production environment with Login PI is where we focus with our Login PI product. So that's testing availability and performance in production, remote user testing. If I have multiple sites external to my data center, I want to test the connectivity from those sites, and then testing new patches before deployment. A lot of this can be done with Login PI. But the focus of our testing today and the results today that we're going to focus on with Pivot3 is in Login VSI. Login VSI as a test tool is easy to install and use. We have our industry standard VSI Max, which helps to measure the responsiveness of the system under load. It comes with turnkey workloads, as in the case of our testing here. You'll see we tested with our knowledge worker. These are workloads that come out of the box. You don't have to create the workload at all, and it works as soon as you just load it up. It's vendor agnostic, so it doesn't matter if you're using VMware or Citrix or Microsoft. It's all going to work the same and produce the same types of results. And of course, if you need to customize a workload, you can. So if you're testing for something like Epic or Cerner or some other line of business application, we can certainly customize workloads to do that. When we're up and running and we've got the system stressed out, you can see, in this quick movie what a launcher, part of our architecture, comprises of. And in this case, you see about 30 different sessions that are running with our virtual users. So these are all connecting to the back-end desktop pool and stressing each desktop with the virtual user, actively using normal workloads like Microsoft Office, movies, internet browsing, you name it, where those virtual users are using those desktops or digital workspaces very, very much the same as the human users would be doing in a production environment. So this gives us a real indication of how that system is going to respond when you do deploy that to production. Now, to characterize that environment, we have two numbers that we look closely at when we evaluate systems such as Pivot3's. That's VSI base and VSI max. And basically, these two numbers are comprised of an indexed measure of latency. So we're doing a lot of things on these desktops, grabbing all of these responsiveness numbers, and we're indexing them into a common number that we use to determine the VSI base and VSI max. And it's considered to give us a good, a good indication of how responsive that system is. So with systems like Pivot3's, we're looking for a VSI base that's good or very good. And as in the case of the testing that we did with Pivot3, we're pretty much very good. They're right at that line between very good and good. I consider this system definitely a high performer, and being able to optimize the images and have good hardware to run that on and get scores that low are definitely a good thing, and something Keith will review with you later. Now that's VSI base, and VSI base is determined by determining the responsiveness of the system when you have only a few desktop sessions running on the cluster. As you can imagine, with all the CPU and memory that cluster is comprised of, the responsiveness should be very good, and in this case it was with Pivot3. Then we have VSI max. VSI max is determined by ramping up that number of users and those number of sessions continuously over time until we find that choke point, or the point at which their user responsiveness is determined to be kind of at the top end of the responsiveness, where we don't want that responsiveness to grow anymore or be slower anymore. And we determine that by, again, slowly ramping up the number of users. And as we ramp that up, the system is going to get more latent and more unresponsive. And that's what we call VSI max, that point. The way that it looks on the graph is as we ramp up the number of sessions, you can see the VSI max index average ramping up with the blue line and then crossing the threshold at the VSI max threshold. And Keith again will review the results we got with the Pivot3, the Pivot3 testing that we did. Now VSI max is, you can see it's determined by this threshold, but this threshold also determines the point at which the resources on the back end are about to be, basically it's a hockey stick effect. At that point, anytime after that point, your latency is going to increase pretty rapidly. And that's what we see here. You can see the little x, and that's our VSI max. The goal of VSI max is to determine how many of these users we can fit on this system and get a great user responsiveness. Now, the validated program by Login VSI is one in which we closely watch over the shoulders and in times work with our vendors to make sure that the testing they're doing is compliant, that it's accurate, and that it's fully transparent in how the system is being architected, tested, conditioned, optimized, and all that stuff. And it's important to do this because with many other options on the market, we want to make sure that when we get into situations where reference architectures are being used in the sales process, you want to make sure they're validated and that they're not biased towards the vendor of choice. And in this case, Pivot3 worked closely with Login VSI to validate their reference architecture and work with us to make sure that this is a trusted reference architecture that can be used in any sales process. And Login VSI stands behind the results of this test. And again, we work closely with Pivot3 in all of the testing that was done. You can find these reference architectures on our website or on Pivot3's website. You just go to resources on Login VSI and look for the link to Pivot3. This is the latest reference architecture we published, and it falls under the strict guidelines of validated by. Now there's some requirements for validated by. It needs to be repeatable and accurate, meaning these tests need to be run over and over and over again and produce the same results to make sure that we're not caching unfairly or something like that. A benchmark mode is a way of locking down Login VSI so that it can be fairly compared to any other reference architecture. In this case, we started with benchmark mode but turned it off to disable OneDrive. If you are familiar with the latest that's going on with the Windows channel updates, OneDrive is something that's been turned on that has a high load when a system is logging in or when a session is logging in for the first time. And this high load can negatively impact the performance of the system. And it is something that we've been able to disable. And that just is the only modification we made outside of benchmark mode. And this is common in all reference architectures moving forward as well. So it falls under that guideline. And of course, we watch the system under stress to make sure it reached VSI max without any artificial or anything getting in its way. And as well as stuck sessions. Stuck sessions are a way of determining is the session able to start, and when it starts, can it complete its job before being asked to log off at the end of the test. The more stuck sessions you have, it can indicate misconfigured system. It can indicate a system that's overly utilized. And in this case, again, Pivot3 rocked it. They got 0 stuck sessions in their testing. Well done. And then some recommendations. Desktop optimizations are highly recommended by Login VSI, as well as BIOS power configuration settings, and of course using Flash and NVMe storage, all 3 of which Pivot3 did in their testing. So we tested Pivot3's Acuity HCI platform with 3 X5 series nodes. Again, Keith's going to cover of these more in detail with you. We used Citrix Virtual Desktop 1808 with the latest Win 10 build at the time. It's important to note that we use the latest because it does include security patches. So this is a system that's been tested that does include some of the security patches that are there for Intel, some of the security patches that are in place by Windows, so on and so forth. The virtual user is the knowledge worker on a 2 vCPU by 3 gig of RAM system using Microsoft Office. So again, we're using more recent and more current Office business productivity software. And they were able to get 501 desktop users in this cluster, in this configuration. So all of this is definitely blessed and endorsed by Login VSI as a validated reference architecture, one that the industry can trust. And I'm sure you'll find that the numbers that Keith and Vikram are going to present to you to also be quite well received and well done. So what I'm going to do is hand over the sharing to Vikram so that he can present a little more about Pivot3. So let me do that, Vikram. All right, Vikram, you should be able to do some presenting now.
All right, can you all see my screen?
Yeah, sure can.
Okay, awesome. Thanks, Blair. So as Blair mentioned, my name is Vikram Belapulkar. I do data center solutions marketing at Pivot3. And I really want to thank Login VSI and Blair especially for their help and support with this validation for Citrix, as well as for hosting this webinar. So what I'm going to do is in the next slides, a few slides, I'm going to go through architecture of Pivot3, what's the technology behind this hyperconverged infrastructure, and really how it applies to solving some of the VDI problems. And then I'm going to pass it back to Keith, and he's going to go through the actual testing that was done, the test configuration, the tests that were run, as well as the results that we were able to achieve. We'll go into details with respect to those as well. All right, so that's for the agenda. So just to level set, hyperconverged infrastructure, I assume some of you are from infrastructure background, but some of you are not. So I just wanted to moment to clarify what a hyperconverged infrastructure means and how is it a change from doing, usual traditional IT infrastructure. So what you see on the left-hand side here is really the traditional way of building IT infrastructure. It's still very prevalent in many of the data centers. The thing about that infrastructure, though, is it's fundamentally it is a silos of server infrastructure and storage infrastructure stitched together with storage area network or some sort of storage networking. Most often, the storage used here are dual controller scale-up sort of NAS or SAN storage architectures. Now, these architectures have come from before virtualization was really mainstream, and we're not really built for the high density reality of virtual environment. Whether you look at cloud environments or virtual desktops environment, you can characterize them by just the density of the VMs, density of the workloads, and the density of IOs that they produce. This really, the one that you see on the left-hand side, traditional IT infrastructure, was invented before that. It has gone through some evolutionary changes over time, but fundamentally the architecture was not built for today's reality. And so on the right-hand side, you see what is hyper-converged infrastructure. Really, it is aimed at simplifying how the data center using industry standard hardware and using software as that intelligence layer to provide infrastructure services for the applications and the workloads about the infrastructure. It helps improve agility. It helps improve operational efficiency by use of industry standards technology. It's simple to scale because of its nature being distributed. So all of those reasons, customers are moving away from traditional three-tier infrastructure to more of a hyper-converged modular infrastructure. And what we do there is the last bullet that you see on the right-hand side. We have a policy-based way of managing this infrastructure, what we call intelligence engine. That's what we provide, the automation that we can provide with that. So just going into details then, Pivot3, so Pivot3 HCI, there are a couple of things that we optimize. Those are, we are leaders when it comes to performance, scale, and efficiency. You'll see some of the largest HCI deployments out in the world, multi-petabyte, routinely about 10 petabytes. They're on, many of them are on Pivot3. They're managed by just a couple of generalists. So it's really easy to manage infrastructure at a large scale. It's really easy to scale from footprint to a large scale. And from efficiency standpoint, the way we are architected, we are able to accommodate more workloads on a on smaller hardware footprint. We are also able to provide better usable capacity the way we are doing fault tolerance. So from efficiency standpoint, we deliver market-leading efficiencies, whether it's for compute or for storage. And then from performance standpoint, we have an NVMe optimized architecture, and I'm going to show you what that is. But the result of that is that we're able to overcome common resource bottlenecks, especially in the IO area, and thus able to provide much performance compared to alternatives out in the market. Right, so just getting into the architecture, what you see here is the foundation of what Pivot3 is built on. So you'll see on the left-hand side, distributed scale-out architecture. What you see there are 5 industry standard server nodes running Pivot3 software, Acuity software on top of it, Acuity Data Center. And really the Acuity Data Center series software is really the one that aggregates resources and provides storage services to the workloads above it. It's different in a couple of ways. So now in this case, you see 5 nodes there. assume that each of the nodes have 16 drives in them. So in that 5-node cluster, we have a total of 80 drives. Pivot3 Activity really aggregates all of these resources, meaning, every single volume that you create is spread across all of those drives. Every single VM leverages all of those drives. And this is really critically important when you start thinking about virtualized environment and virtual desktops, where you have, really high VM density driving IOs, and those IOs are being mixed by the hypervisor. So having this large drive pools, large resource pools to support those is really an ideal thing for virtualized workloads. So Pivot3 does that out of the box with its distributed scale-out architecture, aggregating all of the resources. What you see on the right-hand side is really on top of that scale-out architecture, how we provide fault tolerance. And we use our proprietary advanced erasure coding technology to do that, and we've been doing it for a while. What you see with the erasure coding, a couple of things. One, you're able to realize far greater usable capacity. You see the two parallel lines, which is the replication-based fault tolerance used by many of the HCI alternatives. We use an erasure coding. The orange curve that you see up there is the kind of capacity efficiency or usable capacity you may realize with Pivot3. So you get higher usable capacity, and the efficiency really grows as you scale to a higher scale. What's not probably very evident in that is also in many of the fault tolerance methodologies that rely on cross-node replication, really they are duplicating IOs. So they're not only consuming more capacity than they should, but they're also consuming more IOs in that process than they should, and they're stealing those IOs from the real workload. So in our case, we optimize by eliminating that right IO overhead and also providing better usable capacity in the process. And so on top of that, the multi-tier architecture that we have, what it shows here is what's inside a Pivot3 hyperconverged infrastructure box. You see different sorts of resources. There's the RAM resources, there's NVMe PCI flash resources, as well as there's some Sierra connected hard drives, as well as SSD resources. Now, these resources make up our multi-tier architecture, but they're really actively managed by our quality of service, which is part of the intelligence engine. So the quality of service is based on policies, user-defined policies, govern really the data placement and really what workloads and what data sets are placed where in this architecture is governed by that. Really allows you to simplify how you're managing your SLAs using this policy-based quality of service, as well as the NVMe tier by itself. The NVMe tier architecture being optimized for that, we can provide much better response times. What I really want to point out here is that we're managing this NVMe very actively. It's not used as a dump tier. And so we're able to figure out what needs to go in NVMe and what needs to come out at the right time based on workload performance. Really helps you optimize the IO performance as well as the density in the process. I'll go through this slide quickly. The challenges that we try to overcome around VDI can be in 3 buckets. Right? One is the cost of the VDI implementation itself, which is closely tied to the infrastructure footprint you need to support VDI. We help solve that, and now I'm going to talk about how we do that. The second one is the user experience. Oftentimes, VDI projects fail to take off because they're not able to deliver the sort of user experience that users have come to from their desktops. And so providing that user experience day over day on a guaranteed basis is important. And we have a mechanism, a policy-based mechanism to do that. And lastly, the scaling can be a big issue. Many of the projects start small, but as they start growing and as they start scaling, it becomes complex. The performance drops or scaling becomes unpredictable. So all of these factors, whether it's cost or the user experience or the scaling difficulties, these are really the ones that add risk to your VDI implementation. And I'm going to talk in the next few slides how we can overcome those risks. Right? What VDI does, what Pivot3 does at a high level for VDI can fall in these 3 brackets. One, we can dramatically help you reduce the hardware required to support your VDI. Realistically, you should expect about 30% less hardware on Pivot3 HCI compared to alternatives out there. So that's one, and I'll show you in the next few slides how we do that. But the second thing is the superior user experience. With our policy-based quality of service, we can ensure that the user experience SLAs are always met. And we provide some of the most flexible form factors when it comes to scaling. So I'm going to talk about that as we simplify scaling. Right, as for the less hardware, what you see here is really a 3-node Pivot3 HCI system. You see those 3 nodes on the left-hand side. One of the nodes there is highlighted, and you see the resources within those nodes. There are some SSD resources, And the one that's highlighted is the NVMe resource. As I mentioned before, this NVMe flash storage is not used as a dump here. It's used actively by Pivot3's quality of service to determine, what data goes in the NVMe, what data comes out of it, and what time. As a result, we are able to overcome I/O bottlenecks in the process. And most often VDI, if you think about it, VDI requires you to over-provision hardware in many cases because of the I/O requirements of the workload. In our case, we can overcome that bottleneck and really slash the hardware footprint dramatically. As I mentioned before, about 30% less hardware on Pivot3 compared to other alternatives because of this NVMe optimized architecture. So again, I'm going to talk about user experience, how you can see that. What you see here is our quality of service policies. You see 5 policies there. You also see the different SLAs these 5 policies govern. They're comprehensive set of SLAs around bandwidth, around latency, as well as IOPS. And so you can easily classify your workloads in one of these policies to ensure the workload performance. What I want to point out that these policies are not reservations, or they're not caps or limits. They're really priorities. So that's the way we're able to make more efficient use of resources. For example, if a higher priority workload is not priority, transaction or resource requirements, a system automatically provisions those resources to lower priority workloads. So now how can this be applied to VDI? Here's a quick example of how that could be done. What you see here are 4 different data sets. You see the first one is where all the master images are. So you'll see that it's tagged at policy 1. So that means your master images will always get a high priority, faster, low latency resources. Then you see there are 3 different user pools. The power users, let's think of them as important users of the organization. They're probably doing more intensive work, and they're tagged at policy 1 as well. So they're treated by system as important users. The third one you see there is the knowledge workers. Think of them as back office workers, right? They're critical to the business operation. They're probably not mission critical like power users. So they're tagged at policy 2. And then lastly, the task worker, think of them as call center workers. And they're tagged at policy 4 because they're probably least critical users and least performance intensive workload. And so these policies can be applied, and the system can automatically ensure the performance and priorities. But these policies are also extremely flexible to change. So you can change these policies on the fly, and the performance will affect real time, or you can schedule policy changes like you see here. So easy policies to apply to ensure you classify your user pools with the right priorities, and the system understands those priorities and ensures that the right workload of the right user pool gets the performance when there's a contention. And then lastly, I'm going to talk about the flexibility we offer when it comes to scaling. And you see here some of the form factors in which Pivot3 systems are available. You have one or two systems to choose from, but you also have a broad choice of resources in terms of how many CPU cores, how much RAM, or how much NVMe storage do you need. You can choose a wide range of configurations to choose from. What I want to point out is we do have storage optimized, compute optimized, as well as GPU optimized nodes that can come in really handy, especially in a VDI situation. So one of the can come in handy is see here it's a 3-node cluster. Let's say we are looking at 300 desktops being hosted on this 3-node cluster. In the implementation using many other HCIs, most often I/O is a bottleneck. But in our case, in this implementation, we still have a lot of I/O headroom left. And if the time comes to add more users, we probably don't need more IOs or don't need more capacity. And so we can use our compute nodes, for example, to lower the cost and optimize the infrastructure. They can all be managed together above the hypervisor, and the storage can be provisioned from the initial 3 nodes. It's a very cost-effective way of scaling your infrastructure to accommodate more users. In another situation, you may have a requirement where you have a large storage, for user storage. In that case, you can choose to combine flash as well as hybrid HCI clusters, and you can provision your D drives from the hybrid cluster while you can provision your OS images from C drive, and thus you can balance the performance of those things. So flexible way of able to do that. Pivot3 system can also be linearly, predictably. You can think of them as pods you can have many pods spread across many locations, and they can all be managed together from one user interface. So that really simplifies how you manage this storage system. So yeah, I mean, I would say the three things that Pivot3 helps you do when it comes to VDI is help you reduce your hardware footprint dramatically, help you ensure user experience using this policy-based quality of service, and for scaling, offer you the wide choice and flexibility to cost-effectively scale your infrastructure from pilot to full scale. And with that, I'm on to Keith to talk about the specific Citrix validation testing that was done and the results that were obtained.
Hi, folks. Can you hear me?
Yep, I can.
Okay. So I get the opportunity to chatter about all of the testing that we did jointly with Login VSI and the great work that we were actually able to achieve with this test result that's been validated by Login VSI. Next slide, Vikram. So the test configuration that we used, with more detail here, we used two of our X5 6500 nodes, which are our accelerator nodes with the NVMe tiers. And then the way our product works is we add storage nodes after that. This is actually our smallest system and footprint using our Acuity Data Center Edition version 10.5, which is the latest version of the product that we had at shipping at the time that we did this testing. We used quite reasonable Intel Gold 6138. That's 2-socket, 40-core nodes with 80 logical threads, 768 gigabytes of RAM per node. And in this accelerator, the two nodes, we had 2 terabyte NVMe SSDs for a total of 4 terabytes in the system. And each of the 3 nodes had 16 one terabyte SSDs in it. And this is our smallest footprint that we get to and achieve the results that we had here. Next slide. The test configuration blows up like this. The ESXi cluster is those 3 nodes, and then the network configuration is quite simple with the 4 VLANs there. We have redundancy built into the system. Automatically, this is one of the optimizations or benefits that you get in hyper-converged infrastructure systems. We use the Windows 10 and Office 2016 gold images that were deployed in the testing here. And then the way the tests are set up and running is you have a background management infrastructure. That was a 3-node Acuity cluster that we were using. It's where I run the VMware vCenter software VMs, a couple of Microsoft Active Directory VMs, the Citrix Delivery Controller VM, and Storefront. We ran it separately in a different VM. You have the option with Citrix to deploy that in one VM for the testing and the scaling that we were looking at doing here. We elected to do those separate installs. And then in different VMs, we were running the Login VSI software, and then the launchers were all running on these systems over there. Next slide. Okay, the infrastructure details, a bit more detail here. vCenter, this is for managing the Acuity system and infrastructure servers, ESXi. The Active Directory VMs have the user and computer accounts all managed over there. Citrix Delivery Controller, which manages virtual desktops and does all of those controls for your Citrix deployments. Storefront, and a separate VM, which runs the website applications, and then the Login VSI launchers and drives and file shares. There were 40 launchers in the testing that we did here. Next slide. Okay, and the test configuration results, more of the details. The Windows 10 VMs and the gold images were deployed on the Acuity 3-node system. we use the Login VSI knowledge worker workload. That's with Windows 10 and Office 2016, quite new versions of Windows. As Blair indicated earlier, the only optimization or change that we did to the workload was to disable OneDrive. In the particular version that the timing that we had the Citrix optimizer actually didn't fix the OneDrive, which is why we had to change the workload a little bit. But the VM settings are the 2 CPUs, 3 gigabytes of RAM, and then the typical steps for setting up your servers physically is to set the BIOS settings to high performance. Those are the defaults in our HCI nodes. Anyway, the benchmark of OneDrive disable script were run optimized with VMware tools in the gold image. The Citrix optimizer 12067 was the one that we used in this testing. And then the Login VSI Windows 10 best practices were followed. We had a great opportunity to work very closely with the folks at Login VSI to do all the work to deliver the results that we achieved on the 3-node system here. And then a couple of requirements that are set by Login VSI and the way they run their validated programs is the machines must be pre-booted before each test, and then the system must be rebooted between tests, and that ensures stability and reliability and consistency between test runs. In order to get the validated by Login VSI, we did have to submit 3 validated test results that were very similar in the test results that we've achieved. Next slide. Okay, and the results have been received the Citrix Ready validation, and we are listed on the Citrix Marketplace. They are also listed and validated by Login VSI. Our 3-node Pivot3 Data Center Series HCI using Citrix virtual desktops with the Windows 10 and Office 16. As you transition to Windows 10 and Office 16, these results are versions of Windows and Office that you'll be using in your VDI deployments.
Hey Keith, this is Blair. I just wanted to remark on the fact that, congrats on Citrix Ready, but also I wanted to point out to our attendees also that the slope of this curve, the way it just easily nudges up and to the right, is exactly what we're looking for in these VDI types of solutions. So hats off on a job well done on getting a great base on that and getting that nice performance curve.
Thanks, Blair. And as the results in the graph show, we got to 501 with our VSI Max on 3 nodes. That's a very comparable and wonderful result for Acuity. We do see our competitors typically at 4 nodes getting these kinds of numbers. The base at 806, very close to that very good result. And as Blair pointed out earlier, the stuck session 0. So we had nothing got stuck in this particular testing, and those results were repeated multiple times to receive that validated by Login VSI result here. Okay.
Just one comment. There, Keith. So I'd like to encourage you guys to look at competitors' results as well, right? What are the alternative HCIs and what the results look like? And when you do that, I want you to look at the per node number. So for 500 desktops, it's 67 desktops per node for us, and everybody uses different configurations. So I think to get an apples-to-apples idea, look at per node desktops that can be supported, right? That'll help you figure out, which platform did better. Also, I want to note that this was one of the more demanding workloads, right? Windows 10, Office 16, Windows was patched for security, BIOS was patched for security. And as you guys may know, Windows 10, essentially drops the densities by about half. So given that, I think we have really good numbers in terms of per node density.
Great. And then, of course, just to repeat here, we with the Acuity product, we believe, and we've done a tremendous amount of work in the engineering and the product to deliver the kinds of scaling and less hardware, which Vikram wants you to do that validation and check it out with other results that have been published. Delivering a superior user experience. That's what the knowledge worker testing and workload that Login VSI does in the benchmark. It actually is driving the real world workload, driving your mail and web surfing and videos in that particular workload. And then, of course, we deliver a flexible, scalable architecture that you can start at 3 nodes and grow it to 16 nodes, and then add pods, as Vikram was indicating, as the product scales. And we have a number of real-world deployments on VDI customers that have deployed on Acuity and are quite happy with the performance, scaling, and the costs.
Yeah, and I think, just a comment, what doesn't get captured in these numbers is probably our ability to use compute nodes, right? I mean, in most VDI situations, our compute nodes come in really handy and help with a lower TCO. Unfortunately, that was not something we could capture in the test, but in reality, the TCO could be much lower, especially if you think about adding some compute nodes in combination with the HCI nodes. That flexibility lowers TCO as well as helps simplify scaling.
Right. As you scale up the number of desktops that you want, the difference of the different desktops is we indicated earlier with the knowledge workers, task workers, and power users. We have the ability to deliver a scalable solution that will be extremely competitive and efficient in the kinds of deployments that you'll do in the real world. Next slide. I think this is our last. If you want to schedule a demo, please send us email at acuity.pivot3.com or call the number here, and we'll be happy to set you up for the weekly demos that we do of the product in our own webcasts.
Awesome. Thanks, Keith. Hey, we actually got a couple of questions, if you guys wouldn't mind helping me to answer them. Number one was, how does erasure coding compare to RAID redundancy? Or is this a node-based erasure coding? Can you explain that, Keith or Vikram?
Yeah, so RAID is erasure coding is the replacement for RAID. And it adds the efficiency. Hardware RAID typically covered drive failures, where erasure coding handles drive failures and node failures. So can you go back to the slide, Vikram, for erasure coding? That's a great question. Thank you. Okay, so starting at the left side of the chart, on the right side, at 3 nodes, we're just above 50% on our erasure coding, where many other vendors may still be using hardware RAID, or their erasure coding is not very performant. We have a lot of patents around our erasure coding, so we start out being able to handle multiple drive failures and a node failure in a 3-node cluster. And then as you add nodes, growing up to the 16 nodes, we're at 82% of efficiency, and we're handling 2 copies of the data on our erasure coding with drive capacities. And then as you add more and more nodes and drives, the efficiency continues to improve forward.
Right on.
Okay.
And then, just out of curiosity of mine, coming from the storage world, I would also presume that in VDI it's very write intensive, and write latencies are a big deal. I assume erasure coding also comes with a better write kind of overhead as well as a performance. Is that a true statement?
Correct. Our NVMe tier is used for write caching. And so we take all of the writes to the NVMe tier, and then as needed, or we flushed out the actual disks. So
Gotcha.
we're taking advantage of all of the NVMe flash through the writes.
Great.
Which is not in this particular slide, but
Yep, that's good.
Blair, one more comment about one more comment on the erasure coding. Right, you'll see some of the alternative HCIs are now starting to offer erasure coding because that's the only way to help improve your usable capacity.
Yep.
Right, but not all erasure codings are equally advanced.
Sure.
We've been shipping erasure coding since 2008 in our surveillance products, so we've built from that. Our erasure is an 8th generation. It has very little overhead, and it actually minimizes the write overhead of product protection. Right, but if you compare to some other erasure coding, they can get you better capacity utilization, but in the process, your performance, especially from CPU RAM standpoint, can go down. So our erasure coding is optimized not to affect the performance while providing the capacity efficiency. In fact, some of our patents are mentioned by likes of Google's in their patents. So it's been a very advanced erasure coding shipping for a while.
Very cool. Well, we got one more
that's
question.
A bragging point.
Of course, it's not an easy thing to do. One more question was, what were the results when OneDrive was enabled, or how did the results vary? And since I worked with you guys, I can kind of answer that one a little bit too, and Keith, but feel free to jump in. But to our attendees, basically what we would see in our Login VSI performance curve is we'd see a bump that would happen at the very beginning of the test. And Vikram, if you can head to that slide of your performance curve, I can kind of explain it a little better. The idea is that when your session logs in, OneDrive will fire up and try and sync, and it will take some CPU resources. So if you look at the graph that you see here, right where you see at the bottom of the graph where it says VSI baseline 806, right about that point on the curve, we would see this really strange bump. Now, we see that bump sometimes when the system is not set to high performance mode in the BIOS, but we also notice that this happens with OneDrive as well. When OneDrive is enabled, every session that starts up is going to have a high CPU hit, and then it's going to calm down. So what you would see again is a bump right there, in between the first two vertical lines between 0 and 103. You would see that really strange bump. And when you look at VSI performance graphs and you see anomalies that aren't like a nice sloping curve, and you get bumps and things like that, then we know there's something in the environment that's causing, the system to not perform optimally. And in this case, it was OneDrive. And I know Microsoft has been working on OneDrive a little bit to kind of lessen the impact of that startup. And we've certainly, found this in a number of tests with vendors and enterprises alike. So just as a helpful indication to you. And we may have an article out there as well. So, feel free to reach out to us.
Mark's got a blog up there.
Yeah. Sweet. I don't know if you have anything else to say about OneDrive, Keith.
Yeah, the reason that all the vendors are trying to optimize the performance with the way the testing is set up with Login VSI, and everybody disables OneDrive. In the older versions of Windows 10, it was easier to turn off. As they release their 6-month updates, they've made OneDrive harder and harder for the vendors to disable during the test results. You wouldn't do that in the real world. You'd probably leave OneDrive enabled, but for vendors like us, where we're all trying to, get the best numbers that we can, we disable it. It's part of the Citrix Optimizer. And as I said, the version of Citrix Optimizer that we had in the particular day we were doing the testing,
1.2.0
OneDrive disabled.
Yeah,
it didn't work. And so we worked that out with Login VSI, Blair, and I specifically to change their default workload by just waiting 30 seconds. We didn't change anything else at startup. The test, we waited 30 seconds and then started capturing the results. It's quite simple to modify your workload to do that 30-second delay. And other vendors in that window could easily do that as well as we did.
Great. Thanks, Keith. That's all the questions I had. And I'll pass it to you, Vikram and Keith, to close. But I definitely want to thank you guys for working with us, Login VSI, to validate this solution. Again, we at Login VSI, endorse this as we've gone through and validated just about every setting, tuning, tweak, test, repeatability, accuracy, all of that stuff. And Pivot3 has been a good partner to work through that with. So thank you guys for letting me be a part of that process with you. And I'll let you have any last words before we close the session.
Okay.
Vikram, you have anything? No.
I do. I was on mute. I'm sorry.
Okay.
Yeah, I do. Thank you. I just wanted to thank you and Login VSI. We use Login VSI products extensively internally for testing our platform before releases. It's been tremendous help in benchmarking performance and making sure we're making progress. We also think the change management aspect of Login VSI solutions could be very useful for our customers. In general, we're looking forward to working more closely with Login VSI in helping our customers reduce the risk.
Right on. We can all use it in
the other last point I'll make.
Go ahead, Keith.
Is we've also published results for Horizon View that are up on the Login VSI website. You're welcome to go pull that. Today's results are about Citrix.
Right on. Cool. Yeah, that was a tested with solution by Pivot3. Wonderful. Well, thank you guys so much. Thanks to all you attendees for joining us today. Appreciate your attentiveness on this one. Recordings will be made available later, and thank you for your attendance and participation. We'll talk to you later.